Welcome to 13 Cubed. In this episode, we'll continue our exploration of WSL2 by installing Plaso and Log2Timeline within an Ubuntu 20.04 environment. We'll first need to add the proper repo as we're doing here. In fact, all the steps we're performing are identical to those covered in the Getting Started with Plaso and Log2Timeline episode, which I highly recommend watching if you haven't already. Now that the repo has been added, we'll need to update the available package lists by running a sudo apt update. This will take just a moment. At this point, we're ready to go, so all we have to do is type in sudo apt install plaso-tools. This is going to install the newest packaged release, which means that all the prerequisites and all the necessary tools we'll need will be installed with a single command. Pretty neat. Now, since we've previously covered this, I'm going to speed through this section so we can jump right into the fun stuff. Fast forward a couple of minutes later, and we're done. Let's go ahead and run log2timeline.py, and as you can see, it seems to work just fine. So at this point, we need some evidence. Let's go ahead and jump over to another Windows 10 box and run KAPE so that we can grab some evidence that we can then process with these tools. If you aren't familiar with KAPE, check out this 13 Cubed episode, which covers the tool. Also, look in the description below for a link to a fantastic walkthrough created by AboutDFIR that covers everything you need to know to get started. That aside, in a nutshell, KAPE is a forensic triage utility that can be used to acquire and parse artifacts of interest from a Windows computer system. The artifacts we'd like the tool to grab are called targets. We can then optionally specify any number of modules to run against the collected targets to parse them via any number of forensics tools, providing the examiner with actionable output that he or she can immediately use to investigate a case. That, after all, is the entire purpose of triage. We want to get at the data fast and focus only on what we're most interested in, getting rid of all the other junk. So again, targets collect data, and optionally, you can use modules to parse that data. For our purposes, we're going to be using KAPE solely as an acquisition tool. So let's go ahead and jump in and get started. I'm going to connect a USB flash drive to this Windows 10 Pro virtual machine. On that drive, I've placed the newest version of KAPE as of the recording of this episode. The drive will also serve as the destination to which we tell KAPE to write our collected evidence, which will be contained within a VHDX file, which has then been zipped, but more on that in a bit. So I'll go ahead and physically connect the USB flash drive to this machine. And as you can see, VMware Workstation is asking us where we would like the drive to be presented. I'll choose the virtual machine and then click on OK. And after a few seconds, it has mounted as the E drive. Let's head over to this PC so we can browse the contents of the drive. So I'll double click on E here. I'll then go into the tools directory, and then I'll go into the KAPE directory. You will notice both kape.exe and gkape.exe. Normally, you're going to be using kape.exe, which is the CLI version of the tool. That's what I always use. But there is a GUI wrapper for kape.exe called gkape.exe, and in this episode, I'm actually going to show you that because if you've never seen KAPE before, it may make some of the options a bit more easy to explain. So as expected, there's a UAC prompt because KAPE and gkape both require administrative privileges to run. So I'll go ahead and click yes, and we'll give it just a moment to load the GUI window. I think you'll find the layout to be fairly intuitive. The leftmost side of the screen are target options. That's what we're going to be concerned with. The rightmost side are module options. So I'll go ahead and check Use Target Options. For the target source, I'll click the ellipsis and we'll choose the C drive, which of course is the drive from which our artifacts will be collected. For the destination, as I mentioned before, I'm going to write the data to the E drive, and there's already an evidence directory here. You'll notice that there's a flush option, which is checked by default. That means the contents of that evidence directory will be deleted when the tool is run to make room for this new evidence. Keep that in mind. As we scroll down through this area, these are all of the targets that are contained within KAPE by default. I'm going to choose the topmost target, which is called Basic Collection. This includes all of the standard, most commonly referenced Windows artifacts like prefetch, link files, jump lists, Windows event logs, just about all the typical artifacts you would normally want to have from a Windows box. And it's already there for us. Again, it's called Basic Collection, and it's one of the many included targets. You could, of course, write your own as well. I'm going to check process VSCs, which will process any and all volume shadows present on this machine and deduplicate any of the evidence from those locations as well. So that means we'll get possibly prefetch, Windows event logs, and various other artifacts from the volume shadows as well, which is awesome. For the container, I'm going to choose VHDX, as I previously mentioned, and we are required to specify a container base name. Doesn't really matter so much what you put here. It will end up becoming part of the overall file name, as you will see. But for our purposes, I'll just make up something generic like demo. And then notice below that zip container is already checked for us, which means the VHDX file, once created, will be zipped. And that will become important. We'll talk more about that in a bit as well. So again, for the base name, I'll just type in something simple like demo. All right, and at the bottom of the screen, you are going to notice a command line that's been built out for us based on the options that we've chosen within the GUI. So in other words, you could literally copy that and paste it in an admin command prompt and run KAPE.exe with those options, and it would effectively do the exact same thing. Again, this is just a GUI wrapper for the tool. But let's break down these options. We have, of course, KAPE.exe, which is pretty self-explanatory. Right after that, we have --t source. That is the target source, C:. --t dest is the destination where we would like the evidence to be written. --t flush corresponds to that flush checkbox up above. As I mentioned, this means that the destination, in this case e:/evidence, will be deleted prior to this KAPE run. So any previous files that were in that directory are going to be blown away before the new evidence is written here. So be careful with that. That could be very problematic if you choose the wrong path, though the tool will warn you in the GUI when you launch it. So again, that's that option right there. --target specifies one or more targets. In this case, it's that basic collection, which, as I mentioned, will contain most of the standard Windows artifacts that you would expect. --VSS means crawl any and all volume shadows present on the system and parse those artifacts from those as well and deduplicate them, which is by default. You won't see a flag there present for deduplication because that's assumed unless you tell it otherwise. --VHDX, of course, tells it to create a VHDX file. The base container name is after that, which is demo. Again, that is required. And then --GUI is only an option you would find when you run this from gcape. It just means that the window that's going to open to run KAPE.exe will pause at the end instead of just immediately exiting so that you can see all of that console output. And that's pretty much it. It's built that command line for us. And really, once you memorize those various parameters, you're not even going to think twice about it. You're going to pop open an admin command prompt. You're going to type KAPE.exe followed by your parameters. You're going to hit enter and let it do its thing. But again, the GUI is fairly good if you've never used KAPE before to kind of explain and show you the various options. So all we have to do at this point is click that execute button in the bottom right and let it start running. It's going to end up taking probably 2 to 3 minutes. And of course, I'm not going to make you wait on that. I'll speed through that section. And really, after a couple of seconds in your time, it will be done. And we'll take a look at what we have. So let's go ahead and launch it now. And here we go. Notice that warning message telling us that we could lose data as a result of that flush option being checked. And there's the window. And notice the title bar for the window. Notice the percentage incrementing forward and the current status of what's happening. That's pretty cool. So pay attention to that title bar of that window. And there's all the console output. Again, I'm going to fast forward through all of this so you don't have to sit there and wait on it. And we'll come back when it's done and take a look at the results. And as you can see, the tool is now done. You'll notice the total execution time there in red. And it didn't really take but just a few minutes to grab all of that data automatically for us, which is pretty awesome. So at this point, all we need to do now is take this back to our analysis machine and start looking at it. If we go ahead and browse the E drive here, under evidence, in case you're wondering what it looks like, there is the console log, which is everything you saw in that black window. Again, that's just everything that was on screen there as that was scrolling past. And then the zip file itself contains the VHDX file within it. As I had previously mentioned, it's important that it's zipped because when we actually end up mounting a VHDX, which you can do natively in Windows just by double-clicking on it, it will mount it as read-write, which means you could modify any of the contents of the files within the VHDX, which is not desirable when you're performing forensics. But because we have that original zip file, we can simply re-extract it and be back to our original unmodified VHDX. All right, so with all of that done, it's time to switch back over to our DFIR analysis station, fire up WSL2, and take a look at just how we can analyze this evidence that we've collected. Now let's plug in that same USB flash drive that we used earlier into this analysis machine. And if all goes well, it should mount as the next available drive letter, which is E. And there it is. Let's go ahead and open this up and go into that evidence directory. And there are the two files that we saw previously. I'm going to drag the zip file onto the desktop. And now we will go ahead and extract the contents of that zip file to expose the VHDX file contained within. And there it is. I'm going to reopen this PC, and I want you to pay attention because I'm going to double click on this VHDX file and it should mount. And there it is. It mounted as the next available drive letter, which is F. And there's all the evidence contained within collected by KAPE. So we should be done, right? We just go into WSL2, fire up log2Timeline, point it at the mount point, and we're good. Unfortunately, no. As you can see, WSL2 only sees the C and D drives, not the E USB flash drive or the F KAPE VHDX. Neither of those drives are presented. Even if we use another tool like Arsenal Image Mounter, it still will not be presented within WSL2. So what do? Well, first off, let's go ahead and go back to the Windows terminal and go back into the WSL2 environment. We'll change into the desktop, and we're going to install a suite of utilities called, how do you pronounce it? I don't know, QEMU, something, QEMU-utils, however you want to pronounce it. I say QEMU. And once we do this, we're going to have access to an image conversion utility. See where I'm going with this? We're going to actually type in QEMU-img convert -O to specify the output, which is going to be raw. And then we're going to specify the source and destination. The source will, of course, be the VHDX image that we want to convert, and the destination will be the file name that we want it to be written to, of type RAW, which is like a DD image. So we're simply converting one forensic image file format to another. And as expected, the RAW is, of course, larger than the VHDX. Okay, that's it. At this point, we now have an image format that is natively supported by Log2Timeline. You could try to point Log2Timeline at the VHDX, but as of this recording, it won't parse it. So we'll do the kitchen sink approach as described in that previous Log2Timeline episode I mentioned. We'll write it to plaso.dump and specify that raw file you see there. And we're off to the races. As you can see in the rightmost file column, it's crawling all of the artifacts contained within that KAPE image. So to recap, we simply converted the VHDX image file created by KAPE to a raw image file, which is natively supported by Log2Timeline and the other associated tools within this Plaso toolkit. So I'm going to speed this up and let this finish so that we can go ahead and run the utility that will then convert this raw database into a CSV file that we can finally analyze with Timeline Explorer. So let's go ahead and fast forward through this. That ended up taking a little more than 6 minutes to write that plaso.dump file. So let's go ahead and take a look at the results. I'll do a directory listing here, and you see the plaso.dump file there at the bottom. Let's run pinfo.py against the dump file to grab some basic metadata. This will show us the various parsers and the number of events associated with each, as you can see here, along with various other metadata about the Plaso file. Next, let's go ahead and run psort.py, which is the final utility that will take that Plaso database and write it into a CSV file in our case. So run psort.py, the output will be L2T CSV, which is the classic or legacy Log2Timeline format. We'll save it as timeline.csv, and of course we'll feed it the plaso.dump file. UTC is the default time zone. Now this is going to take several minutes to process as well, and yes, I'll fast forward through this for you as well so you don't have to wait on it, but the result of this will be a timeline.csv file that is our final product, so to speak. We can then open that within Timeline Explorer and get to work analyzing the fruits of our labor. That ended up taking about 8 minutes, so let's go ahead and look at the resulting timeline.csv file. You'll see it there at the bottom, and it is fairly large at like 668 megabytes. Normally, this is not the way we would do things, right? We would generally have some sort of time range that our incident would revolve around, and we would kind of slice and dice the data accordingly. Refer to that Getting Started with Plaso and Log2Timeline episode if you want to learn more about how to use these tools, but for the purposes of the demo, this will work fine. So here's Timeline Explorer, and all I'm going to do is drag the timeline.csv file from the desktop into Timeline Explorer. Be patient, again, this is a large CSV file, and once it loads, we'll be able to get right to analyzing the data. And we're done. So let's go ahead and maximize the Timeline Explorer window here to make it easier to view the data. Notice in the bottom left, I have a filter applied from a previous investigation. I'll click the X to get rid of that. And in the bottom right, you'll notice the total lines and visible lines match at more than 1.2 million. Remember that we would normally use psort to specify a date and time range to narrow the scope of the timeline and not literally look at a timeline of everything on the machine. That's not efficient at all. It would not make for a good investigation. Let's play around with some of these artifacts and choose a couple of things related to USB device forensics as an example. There you can see the SanDisk Ultra USB flash drive that I had connected to this machine, the one from which we ran KAPE. And there are numerous other artifacts we could choose from here as well. That just gives you an idea of what you can look at. This is not an episode about how to use Timeline Explorer or anything like that. You get the general idea though. We're just playing around, showing you what data is available. Let's clear our filters and look at one more thing. How about Windows Prefetch, which should be color-coded in red? This, of course, shows us program execution. This is a very important artifact. There's an entire deep dive episode covering this. If you haven't already seen it, I would encourage you to check that out. And there's all of our prefetch data. So to recap everything we've done here, let's talk about the purpose of this episode, right? We have been experimenting with WSL2 and using it to run tools that we would normally run on a dedicated Linux box or a Linux VM to parse Windows artifacts. But instead of having to do that, we just run them natively within this environment. You saw in a previous episode Volatility 3, and in this episode Plaso and Log2Timeline, and there are plenty of other tools I'd like to cover as well, but keep in mind, this is just testing. A lot more testing needs to be done to verify that there aren't any issues with these tools. Again, we're experimenting here, trying to understand the capabilities of WSL2 as it relates to digital forensics. So what did we do? We went to a Windows 10 box, ran KAPE, grabbed some evidence in a VHDX format, which was then zipped, went back to our analysis machine, unzipped the zip archive to expose the VHDX. We then saw that we couldn't just mount the VHDX in Windows and point to it directly with WSL2. That would be too easy. But instead, we actually ran the QEMU utilities to convert that image file format, the VHDX, into a raw image file format, which is supported by Log2Timeline. Remember, Log2Timeline can be pointed at a mount point or at certain image files, such as EO1s and RAWs. But as of the time of this recording, not VHDXs. So that's the whole reason we converted it from a VHDX to a RAW. But otherwise, that wraps up everything I wanted to cover in this episode. If you have suggestions for future WSL2 episodes or any kind of future episode, drop a comment below and I'll be sure to check it out and add it to my suggestion list. As always, thank you for watching, thank you for subscribing, and I will catch you in the next 13 Cubed episode.